Hello students, today we will be discussing about trigonometric ratios. So this is the introduction of the chapter trigonometry. It is the branch of mathematics. Its application mainly we will be able to see in science and engineering. So it is very much needed for further studies. So we are just introducing this topic in standard 9. It's a continuation you will be able to see in standard 10. It will be almost similar things you will be doing in standard 10. But from standard 11 onwards, almost all the topics you will be able to see its application. So it's very important. So we will start with the first topic of this branch, that is trigonometrical ratios. So before going to the ratios, I will say about some general conventions what we use in triangles, that is in trigonometry or in triangle we will go for certain general conventions. That's I am going to say it. See, usually we know triangle, its vertices is denoted by capital letters. For example, if I write a triangle ABC, let me draw the corresponding triangle. This is the triangle ABC, whatever it may be, it's any type of triangle. So vertices are denoted by capital letters, and then the small letter, the corresponding to capital A, the small letter we know B, the small letter is A, and corresponding to B it is small b, and corresponding to C we go for small c. So what it will be in this triangle? We know the vertices A is this, that is, this is the angle. The side opposite to this angle, that is this side, BC. BC is denoted by small a, and the side opposite to the angle B, that is AC, is denoted by small b, and the side opposite to angle C, that is AB, is denoted by small c. This is the general convention we use in trigonometry. So small ABC is always opposite to capital ABC. This you have to know it. This is very much needed from standard 11 onwards, but this year onwards we will try to include these things, since you must learn this. Then only it will be easy for you in higher studies. So small ABC is opposite to capital A, capital B and capital C. This is a general convention we use in trigonometry for triangles. Small ABC is denoted by what? You have to know it. Now when it comes to, I said it is applicable for any triangle, even if it is a right angle triangle also the same way. Okay, so all triangle, this notation we will use it. Now another thing in trigonometry, another convention we use, usually if you draw a right angle triangle, we say this is base and this is, we say, height, and this is hypotenuse. We know hypotenuse is always opposite to 90 degree, and this is base and this is height. This is the usual convention we use in a right angle triangle. But when it comes to trigonometry, so it is not necessary to go for always base and height. See, if a triangle is given like this, right angle triangle, I am naming it ABC. Here there is no doubt BC, it is opposite to 90 degree, it will be hypotenuse. This is not base. If you say, usually we say this is base, but in this triangle it is angle opposite to 90 degree is always hypotenuse, so this is hypotenuse. Now if I ask about base and height, many will have problem. Many will have problem which is base, which is height. Some will say this is base, some will say this is base. So that problem will be there. So in order to avoid that, in trigonometry we go for another notation. So if I take, let it be, this is one angle I am taking, let it be this angle, let it be with theta. It is a Greek letter. Angle, it is denoted by theta. In trigonometry we use this theta. This is theta angle, or this is another angle phi. Okay, like this notation we use for in trigonometry. So this angle I have named it as theta. With respect to this theta, this is AB, we can say with respect to theta it is opposite side. So usually we write this as opposite side. This we take it as opposite side, and this is the side near to this angle. This side is near to this angle. This we take it as adjacent side. This notation, that is opposite side and adjacent side, if you learn, it is very good always. Otherwise you will have a lot of confusion in trigonometry. So opposite side means always the angle opposite to the angle, whatever the angle is given. The side opposite to whatever the angle is given. Adjacent side is nearby, the side which is near to the angle. So opposite side, adjacent side, hypotenuse, these three notation I will use in trigonometry. I will not go for height and base. Since height and base if I use, many will have problem. So see here also, if I take this is theta, then we can say this is the side opposite to theta. So this we say it as opposite side. We say this is opposite side, and this is near to this angle. So we say it is adjacent side, and this is always hypotenuse. That is the side opposite to 90 degrees hypotenuse. So this convention I am going to use in this topic. That is opposite side, adjacent side, and hypotenuse. So whatever be the triangle, in this way if you do it, it is easy for you to handle it. Okay. So these are the notation I am going to use. Opposite side means it is opposite to the angle theta. Adjacent side means the side near to the angle theta, and hypotenuse means always opposite to 90 degree. Okay. Now I am going to say about this convention. We will use it. Now I am going to say about trigonometrical ratios. So what we are going to do in trigonometry, we are going to relate the sides of a triangle with the ratios of the sides of a triangle with the angle. That is the relationship we are going to do here. That is in trigonometry mainly we are going to deal with that only. That is the ratios of the sides of a triangle, how it is related with the angle. In small class you studied in a triangle only one relation, that is the relation connecting the angles. Relation connecting the angles of a triangle, that is only about angle. That is, we know angle sum property, sum of the three angles of a triangle is 180 degree. That you studied. And another one more result you studied about the sides. That is, sum of any two sides is always greater than the third side. So that means these two relations you studied in small classes. One is regarding angle, one is regarding sides. But in this topic, we are going to relate angles with the sides. That is the main difference we are going to see here. So for that, I am seeing a right angle triangle. I need a right angle triangle. A, B, C, I am naming it. I am taking, let it be one of the angle, let it be this angle, I am taking it as theta. And we know this is hypotenuse. This is hypotenuse. This side is opposite to theta, so I am writing it as opposite side. And this side is near to this, so we say it as adjacent side. So these are the notation already I told. So these are the notation we are going to use here. So the first relation I am going to say the relation connecting opposite side and hypotenuse. That is, if I divide opposite side with the hypotenuse, there is a ratio. Ratio connecting these two sides. It is denoted by the ratio sin theta, sine of this angle. We write like that as sin theta. Sin is the name of the ratio. Sin theta. Theta is the angle. Sin theta is equal to opposite side divided by hypotenuse. That we can use, that is AB by AC. We can say it as AB by AC. This is the first ratio, that is number one. Now the second ratio, the ratio connecting adjacent side and hypotenuse. adjacent side and hypotenuse, that is named as cos theta. Cos theta. That is adjacent side by hypotenuse. So that is BC by AC. So that is the second ratio, and now the third one. You have to memorize these things. Now the third one is relation between opposite side and adjacent side. That is known as tan theta. Tan theta. This is the name of the ratio. Tan theta is equal to opposite side by adjacent side. These are three basic ratios. That is sin theta is opposite by hypotenuse. You have to learn, you have to memorize these ratios. Cos theta adjacent side by hypotenuse. Tan theta is opposite side by adjacent side. Opposite side is AB by BC. Now if I go for the reciprocal of these things, so the reciprocal of sine theta, we write it as cosec theta. It is the reciprocal ratio. We say it as one is known as reciprocal ratios. Reciprocal ratios. What are the reciprocal ratios? One is cosec theta. Cosec theta actually is the reciprocal of sine. We say it as 1 by sine theta. Or we can say cosec theta is hypotenuse by opposite side. So if you know these three things, other things easily you can memorize. So cosec theta is the reciprocal of sine, and now reciprocal of cos. Reciprocal of cos it is sec theta. Sec theta is equal to 1 by cos theta, means it's reciprocal. That is sec theta is 1 by cos theta. Now the next one is the reciprocal of tan, that is known as cot theta. That is 1 by tan theta. So these are the first three. If you know, the next three automatically you can learn it. It's just a reciprocal of the first three. So main thing is memorizing of the first three is important. Other three you have to don't mix up. See sin theta easily you can memorize like that. If it is starting with S sin, here it is starting with the C. S becomes C. Otherwise, when you will have problem, what is the reciprocal of sin theta? If somebody asks, you will have doubt whether it is cosec or sec. So if it is S is there, the reciprocal becomes C. You will start with the C cosec theta. The same way, if it is C is there, you can see it will be starting with this S. So these two letters are interchanging. That way you can easily memorize it. So sin theta's reciprocal is cosec theta, and cos theta's reciprocal is sec theta, and then tan and cot. That easily you can memorize it. These are the 6 basic ratios. So in this, the first 3 if you memorize, the other 3 automatically you can learn it. So and the conventions you have to memorize it. So I am not going for height or base or anything like that. I am using always opposite side and adjacent side. Since this is very much needed, it's not necessary to give always triangle like this. Triangle sometimes you may give in tilted form. Then you will have problem with what is base and what is height. That can be avoided with the adjacent side and opposite side. So memorize, better you memorize this way only. Don't try to memorize base, height and all. That will create confusion when you go to higher classes. So this is, so now if I connect this again, if you see this, if I cross multiply, you can see one result. Cosec theta into sin theta, if I multiply, it will come 1. See, cosec into sin is 1. The same way, sec into cos is 1. Cot into tan, that is also 1. So there is one set of relation can be made from here. And one more thing we can write it, that is tan theta. Tan theta can be written as the combination of these two, tan theta. See, if I divide sine with the cos, that is this expression, if I divide this, what will happen? This hypotenuse will get cancelled. If I divide sine with the cos, hypotenuse will get cancelled. Leftover will be cos by, leftover will be opposite by adjacent. Opposite by adjacent means we know what is it? Opposite by adjacent is tan theta. That means we can say tan theta as sin theta by cos theta. That is one relation. Tan theta is equal to sin theta by cos theta. Just if you divide these two, you will be able to. If you divide sin with the cos, hypotenuse will get cancelled. Opposite by adjacent will be left over. That is tan theta. So tan theta is equal to sin theta by cos theta. This is also one relation. We need this. And then naturally cot. What will be cot? It's a reciprocal. It's a reciprocal means what will become cos by sin. Okay. So these relations we have to learn it. Then only we will be able to do the sums from the exercise. So these are the basic things you need. And then some more results. That is the results connecting squares of these ratios. Okay, that we say it as trigonometrical identities, we will say. So that is also I am going to discuss. That is also we need in the first exercise. What is trigonometrical identities? We say generally identities. This identity is very much needed in proving many questions. So I am going to discuss about identities. Identities. So there are three sets of identities. I am going to say the first identity, first set. See a triangle, right angle triangle I am drawing it. Let it be A, B, C. I am using the normal conventions. I said this capital A, naturally this will be small a, this side will be small a. This is capital B, so this will be small b. This is C, so this side will be C. I can write this. I am dealing with one particular angle, one of the acute angle. Let it be this angle. I am taking it as theta. This is theta. Alright. Now, if you see these three sides A, B, C, it's a right angle triangle. We can apply Pythagoras theorem. If I apply Pythagoras theorem, I will get A square plus C square. A square plus C square is equal to B square. Pythagoras theorem I applied. Now what I am going to do, I am dividing, this b square I am bringing this side, or we can say I am dividing with the b square. If I divide with the b square, this becomes a square by b square, this becomes c square by b square by b square is 1. This can be written as a by b whole square, this is c by b whole square is equal to 1. I can write like this. Now if you see, I am going with the normal conventions. So again, theta, with respect to this theta, this side we say it as opposite side, this is our opposite side, and this is our adjacent side, this is our adjacent side, and this is always our hypotenuse. Alright, so if you see A by B means what? Adjacent, A is adjacent side by hypotenuse. Adjacent side by hypotenuse, if you know the ratio, adjacent side by hypotenuse is known as cos theta. So therefore this can be written as cos theta whole square, I can write it. Again C by B, if you see C is opposite side, B is hypotenuse, opposite side by hypotenuse. Opposite side by hypotenuse is known as sin theta. So this I can write as sin theta. Whole square is equal to 1. Now this here when you will have problem. So what is the meaning of cos theta whole square? Cos theta whole square means it's just cos square theta. It's no need of putting power for theta. It is cos square theta. This is the way we have to write in trigonometry. Cos theta whole square means cos square theta. And this is sin theta whole square is sin square theta is equal to 1. This is the first identity what we are going to make before. First identity, cos square theta plus sin square theta is equal to 1. You have to memorize this. Or we can say sin square theta plus cos square theta is equal to 1. So here this power part you have to be careful. Whatever it may be, it is written like a sin theta whole to the power 5. Its meaning is sin to the power 5 theta. This power is for the function, that is sin to the power 5 theta. Whatever it may be the power, it will come here. See if you write like this, sin theta to the power 5, it is totally different. It is wrong. This convention is wrong. Sin theta to the power 5 means sin to the power 5 theta. So here, so same thing applied. So sin square theta plus cos square theta is equal to 1. From here I can write two more results. One is cos square theta. Cos square theta is equal to 1 minus sin square theta. I taken sin square to that side. Again sin square theta is equal to 1 minus cos square theta. This is the first set of identity. Sin square theta plus cos square theta is equal to 1. From that another two more I can make out. Similarly, so here I divided with b square. Instead of dividing with the b square, if you divide, you can divide with a square, then we will reach a result. Even if you want, you can divide with the c square, then you will get another result. So if you do those things, you will be able to reach another set of identity. That's why I am going to write directly. I am going to write. So one identity will be sec square theta minus tan square theta. Sec square theta minus tan square theta is equal to 1. From this we can write sec square theta is equal to 1 plus tan square theta. Again tan square theta is equal to sec square theta minus 1. So the first one, if you memorize, other two things automatically you can write. Sec square minus tan square is equal to 1. It's not plus, it is minus. And it's also sec square first. Sec square minus tan square is equal to 1. So this is another set of identity. So one more we can make out. I said we can divide with the a square or c square. So another one more we can make out. What is that? It is cosec square theta minus cot square theta is equal to 1. From here, cosec square theta is equal to 1 plus cot square theta, and even cot square theta is equal to cosec square theta minus 1. So this set of identities you have to memorize. Means in all cases the first one, if you know the first one, here the first one, here first one, and here the first one, if you know, other results you can make out from that. So these are the things we required in the first exercise. So we have only one exercise in this chapter. We have only one exercise. So these results you have to memorize. Then only you will be able to do the sums. So in trigonometry you can see you have to memorize a lot of results. In standard 9 we are learning only very few results. But when it comes to standard 11 and on, you have to memorize a lot of results. So these are the results: basic ratios and plus identities. These are the results required to do the sums from the exercise. Now we will try to do few questions from the exercise. Exercise 17. First of all, we will do question number 2a part. Diagram. See, right angle triangle is given in tilted way. So this is the naming A, B, C. The sides are given. This is 6 and this is 10 centimeters. Question is, we have to find out from the figure. We have to find out the sin B. That is the first part. Second part, we have to find out cos C. Third part, we have to find out sin B plus sin C. And then one more part, fourth part, we have to find out sin B into cos C plus sin C into cos B. These four parts we have to find out. So it is given this. In the right angle triangle, two sides are given. First of all, we will find out the third side by Pythagoras theorem. That is AC square. We can find out AC square is equal to hypotenuse square minus this side, that is 6 square. 100 minus 36, that is 64. Therefore, AC is equal to 8. So AC we got 8. Write the figure AC is 8. Now we have to deal with this B. The angle is given B. So this is the angle. So you have to know which angle. Sin B. This is the angle. So first of all, sin B. We know sin theta. I am given sin theta is equal to opposite side divided by hypotenuse. So if you know this relation, sin B with respect to B, opposite side is AC. and hypotenuse is 10. That is BC. So it will be opposite side means 8 by 10 we can write. Directly we can write this is equal to 8 by 10. If you simplify further, it will be 4 by 5. I divide with 2. So this is the first part. Sine B with respect to B, opposite side this is, hypotenuse is this. I do know the ratio, then only you can do it. Okay, now second part. Cos C. Cos C, here the angle is C, this is the angle. This is the angle, so remember that this is the angle cos C, this is, and cos theta means we know cos theta is adjacent by hypotenuse. So cos C with respect to C, adjacent side is side near to that 8 by hypotenuse, that is 8 by 10. 8 by 10. So this is also 4 by 5, that is cos C. Now we need the next one, sin B plus sin C we need. Sin B already calculated, now sin C we need. So first of all I am finding out sin C. Sin C, this is the angle C. Sin theta means we have to now memorize we have to know the relation. Sin C is opposite by hypotenuse. Opposite by hypotenuse. If you use that, sin C with respect to C, opposite is 6 by 10. That is 6 by 10. This is equal to 3 by 5. That is sin C. Now we need sin B plus sin C. So now sin B plus sin C is equal to sin B plus sin C. Sin B we calculated here 4 by 5 plus sin C we calculated here 3 by 5. So ultimately it becomes, if you simplify, it is coming 7 by 5. 7 by 5, that is sin B plus sin C. This is the third part. Now fourth part. We need a sin B already we calculated, sin B, cos C also we calculated, sin C we calculated. Now we need cos B, So first of all we will find out cos B from the diagram. Cos B I am finding out. Cos B, this is the angle B. We know cos theta is adjacent by hypotenuse. If I use this cos B, this is B, adjacent side is side near to that 6 by 10. 6 by 10, that is 3 by 5. 3 by 5. Now the fourth part we have to find out this. So I will substitute, already everything I calculated. Sin B is 4 by 5. Here I put 4 by 5 into cos C. Cos C is 4 by 5 plus sin C we calculated here 3 by 5 and cos B we calculated here 3 by 5. So if I simplify, 16 by 25, 9 by 25, ultimately it is 16 plus 9 by 25. So it is coming 25 by 25, it is 1. So this is question number 2A part. See, here the triangle was given in the tilted form. You will have problem with which is height and base. So that the opposite side, adjacent side will help you a lot. That is why better you will learn by those conventions. Okay. This is one type of question. It is important in exam point of view. So this is question number 2A part. Now we will try to do one more question. One more question we will do it. That is question number 3A part we will do it. Question number 3A part. Diagram is given. Here one altitude is there. A, B, C, D. This side is given 13 centimeter. BC is given 5 centimeter. And the whole length is given 21 centimeter. Question is, and here the angle is given theta. We have to find out the sec theta. That is the question. We have to find out sec theta. There's a triangle and one altitude AD is given and the sides are given 13, 5 cm and 21 cm. We have to find out sec theta. We know sec, that is S standing with S, is the reciprocal of cos theta. And cos theta means we know adjacent by hypotenuse. Those relations here, memorize it. Cos theta. See theta, we can see theta is part of which right angle triangle you have to see. There are many triangles in this, but you have to see the right angle triangle. Theta is part of which right angle triangle? This is the right angle triangle. Theta is part of this right angle triangle. So with respect to this right angle triangle, we need its adjacent side and hypotenuse. With respect to theta, adjacent side here it is BD. BD is we can write it since the whole length is 21 and this is 5. Naturally BD will be from the diagram. BD we can write it directly 21 minus 5, that is equal to 16. That is BD we got it as 16. Now with respect to this right angle triangle, hypotenuse is AB is the hypotenuse. AB I need. So AB, how we can find out? So for finding AB, here you see in this right angle triangle, if you look at this right angle triangle, here hypotenuse 13 and base it is 5. So I can find out the height AD by Pythagoras theorem. But if I look at the right angle triangle ADC, from ADC I can find out AD, that is AD square. If I go for that 13 square minus 5 square, that is 169 minus 24, that is 25, that is 144. So AD is 12. So I got this AD, this proportion I got it as 12. AD I got 12. Now you look at the triangle ABD. If you look at the right angle triangle ABD, we can find out the hypotenuse, that is AB square. AB square is the hypotenuse. So it is 16 square plus 12 square. This is 256 plus 144. If I add, it is coming 400. Therefore, AB is equal to 20. I got AB is 20. This portion I got it as 20. AB is 20. Now we can find out the sec theta. Therefore, sec theta, it is the reciprocal of cos. That means it will be hypotenuse by adjacent. Hypotenuse by adjacent with respect to theta. Hypotenuse is 20. By adjacent side it is 16. So if I divide it with 4, 4 will go here. 5 times 5 by 4 is the required ratio, that is sec theta is equal to 5 by 4.